The first example we're going to look at is simplifying sine inverse cos of x. Now what this means is at one point we had cos of a particular angle and it gave us the result x. So if I draw this up in a right angle triangle, let's call that any angle A. If cos of A was equal to x, therefore my adjacent is x and my hypotenuse is 1. And then using Pythagoras' theorem, we can obviously establish that that third side is the square root of 1 minus x squared. Okay, so where do we go from here? Is I've got cos A is equal to x over 1. And I'm just going to confirm that that is the same as any angle, again in this example we've just used A, is equal to cos inverse x. Now let's use this A and bring it back into our example. So therefore if I want sine of cos inverse x, this is essentially the same as sine A. So sine A is equal to the opposite over the hypotenuse, leaving you with the square root of 1 minus x squared over 1, and obviously that's just square root of 1 minus x squared. And then we have it. Sine of cos inverse x is equal to the square root of 1 minus x squared. In the next example, we're going to try and prove that the inverse of sine x plus the inverse of cos x is equal to pi on 2. So let the inverse of sine x equal to theta. And from that, we can therefore establish that x is therefore equal to sine theta. And then from complementary angles, we can deduce that sine theta is the same as cos of pi on 2 minus theta. And then to get pi on 2 minus theta on its own, I'll be left with cos inverse x is equal to pi on 2 minus theta. Now remember at the start, we had let theta equal to sine inverse x. So now let's replace that theta with sine inverse x. And now I've got cos inverse x is equal to pi on 2 minus sine inverse x. Move your sine x over to the other side. And I've got sine inverse x plus cos inverse x is equal to pi on 2. And I've proven that. Okay, for our last example, we're going to look at inverse sine x minus inverse cos x is equal to pi on 6. Now remember, we previously solved that the inverse sine of x plus the inverse cos of x was equal to pi on 2. So what I'm going to do is I'm going to replace the inverse cos of x with pi on 2 minus sine inverse x. And that's again from our previous proof. From here, I've got now sine inverse x minus pi on 2 plus sine inverse x is equal to pi on 6. Now let's gather our sine inverse x together, and I've got 2 sine inverse of x is equal to pi on 6 plus pi on 2. And as you can see, I brought that pi on 2 over to the other side. Now as you can see here, it's just basic, gathering like terms and simplifying. So now I'm going to bring this 2 over to the other side, and I've got the inverse sine of x is equal to pi on 3. And from our inverse properties, I can then write this as x is equal to sine pi on 3. And in exact form, that gives me x is equal to root 3 on 2.